Welcome to today's JSS 2 Basic Technology lesson on mechanisms, specifically gears and pulleys. Mechanisms are devices that transmit and transform motion and force. They are found in machines all around us, from bicycles and engines to lifts and factory equipment. A mechanism is an assembly of moving parts that works together to transmit or change force, speed, or direction of motion. The study of mechanisms is a key part of mechanical engineering. Let us begin with gears. A gear is a toothed wheel that meshes with another toothed wheel to transmit rotary motion and force. When two gears are in contact, the teeth of one gear fit into the teeth of the other. As the driving gear turns, it pushes the teeth of the driven gear, causing it to rotate as well. Gears serve several purposes. They can change the speed of rotation, change the direction of rotation, multiply force, and change the axis of rotation. The speed ratio, also called the gear ratio, determines how many times the driven gear turns for each turn of the driving gear. The formula is gear ratio equals number of teeth on the driven gear divided by the number of teeth on the driving gear. If the driving gear has 10 teeth and the driven gear has 30 teeth, the gear ratio is 30 divided by 10, which equals 3. This means the driven gear rotates once for every 3 rotations of the driving gear. The driven gear rotates 3 times slower, but with 3 times the torque, the turning force. This is a speed reducer and torque multiplier. If the driving gear has 30 teeth and the driven gear has 10 teeth, the ratio is 10 divided by 30, which equals 1/3. The driven gear turns 3 times for each turn of the driving gear. It goes faster but with less torque. This is a speed increaser. In a simple pair of meshing gears, the two gears rotate in opposite directions. If you want the output gear to rotate in the same direction as the input gear, you add an intermediate gear called an idler gear between them. Types of gears include spur gears, which have straight teeth parallel to the gear axis and are the most common type, used in clocks, machines, and automobile gearboxes; helical gears, which have angled teeth that engage more gradually and smoothly, producing less noise and vibration than spur gears, used in car gearboxes and industrial machinery; bevel gears, which have teeth on a conical surface and are used to transmit motion between shafts that are at an angle to each other, the rear axle of a car uses bevel gears to transfer power from the propeller shaft to the wheel axles at 90 degrees, and rack and pinion, which converts rotary motion to linear motion. The steering system of a car uses rack and pinion to convert the steering wheel's rotation into the sideways movement of the front wheels. Now let us study pulleys. A pulley is a wheel with a groove around its rim through which a rope, belt, or chain passes. Pulleys are used to lift loads, transmit power between shafts, or change the direction of a force. A fixed pulley changes only the direction of the force. You pull down on the rope and the load goes up. The force needed equals the weight of the load, no mechanical advantage. But the change of direction is very useful. It is more natural and easier to pull down than to pull up. A movable pulley is attached to the load rather than to a fixed point. The rope is attached to a fixed point, passes under the movable pulley, and the other end is pulled. This arrangement gives a mechanical advantage of 2. You only need half the force to lift the load, but you must pull twice the distance. A block and tackle is a system of multiple pulleys, some fixed, some movable, working together. The more pulleys in the system, the greater the mechanical advantage. If you have a block and tackle with 4 rope sections supporting the load, the mechanical advantage is 4. You apply 1/4 of the load's weight but must pull the rope 4 times the distance the load is lifted. Velocity ratio, also called the pulley ratio, in belt and pulley systems determines speed changes. If a small driving pulley of 100 mm diameter drives a large pulley of 400 mm diameter, the large pulley rotates at 1/4 the speed of the small one, but with 4 times the torque. This is used in fan drives, lathe drives, and conveyor belts. In Nigeria, pulleys are used in water wells to lift buckets, in building construction hoists to lift materials, and in factories on conveyor belts and machine drive systems. Gears are used in bicycle drivetrains, car gearboxes, water pumps, and industrial machinery. Understanding gears and pulleys gives you insight into how machines work and how engineers design systems to multiply force and change speed. This knowledge is foundational for anyone pursuing careers in mechanical engineering, automobile technology, or industrial maintenance in Nigeria.